infrastructure. One of the greatest challenges for us as University of Hawaii system is that we are literally in the middle of the Pacific. Data, as you can imagine, for a higher education institution is a very, very important commodity for us. We've been able to partner with RTI and CUS so that 100 gig capacity initially on CUS is hugely important to us to make sure that we have the capacity to service our community. Astronomy is one of the largest current users of our capacity, of our long-haul capacity, to both the United States as well as to Australia and to Asia. What we see as a continually growing demand from our astronomers is the need to push larger and larger data sets. You're looking at light coming from maybe hundreds or thousands or millions of years ago that's traveled across these long distances.
These big telescopes tell us a lot about the universe because they're able to probe back into the early time of the universe and give us clues about what happened back then.
You've got 10 meters of collecting power and an incredible sight. We have a single isolated peak. The wind blowing across the ocean, it becomes very smooth when you're 14,000 feet up, so it doesn't distort the image. I don't think that there's anyone that challenges that it's the best observatory site in the world. Haleakala is very similar. It's not quite as high, but we also have a single isolated peak.
The projects that are up there are also about trying to look for objects that are much nearer to us.
We'd look pretty foolish if we were wiped out by an asteroid that we didn't see coming, and so the first step is to look for them.
The Pan-STARRS project, for example. It takes a look at objects in the near-Earth sky and tries to plot out literally which ones are headed our way and which ones that are headed really close by our way, which is something that, it's not just material for movies, it's real and stuff happens.
So this is the Pan-STARRS control room. The Pan-STARRS telescope is a remotely operable telescope. So if you see in the screens back there, Joanna is preparing for her night of observations. Pan-STARRS has been so successful that they have discovered more asteroids than everyone else in the world combined for the last several years. Pan-STARRS 2 is going to enhance the surveys. Having two telescopes means that they can cover the entire sky twice as fast.
The Pan-STARRS data is very challenging. The camera produces over 1.5 billion pixels per exposure, and it's taking 500 exposures per night. And so searching that volume of data every single night for moving objects is very challenging.
So as these instruments get much more sophisticated, you typically see orders of magnitude increase in the level of detail that these instruments can pick out of the sky. What that translates to, though, is multiple levels of magnitude increase in the amount of data that gets created from these instruments. And that data has to go someplace for it to be useful. When we initially set out to acquire capacity, we were looking primarily at the Hawaii to LA for CUS. But in the process of doing that, we were also able to acquire capacity Hawaii to Guam. Guam is actually a great point at which many cables, both current as well as planned, allow us to interconnect traffic to the rest of the Asia Pacific region.
The cable station alone, it brings in both the east and the west, and so that's a 20 terabit system, as they keep saying, and so it's a lot of capacity for a system on Guam. And when we were building, we were talking with the different agencies where we could land the cable, and so what we did was went ahead, built some extra seaward ducts, and the station that we built, it was just, it was enough to handle 5 cable systems right now.
We started talking with Russ Matalich back in 2012. And so that relationship with Russ has probably been nearly 6 years now. And everything that we said we were planning or intending to do has happened. And so we're looking forward to obviously all the new growth that's being planned for Guam as well.
Lots of cables get talked about that never get developed. That's one of the things we like about working with Russ, is that these projects are real projects with real engineering behind them, real business models behind them. They go to the right places, and they enable us to meet the needs of our users and deliver that enterprise traffic in a timely and efficient manner.
We can interact with not only our friends in the University of Guam and the surrounding institutions, but also provide other paths directly to Asia through Hong Kong, and then north to Japan and south to Australia. We expect the ability for us to come to the table with capacity on CUS to be something that helps this collaboration grow a lot into the future. So we're very excited that our friends from ARNet are involved, and also that our friends from Japan are involved to make sure that we can add to the networking fabric in the region. This is cool stuff. The great thing about working for the university and about working with partners from around the world is you get to work with a bunch of not only really smart people, really smart engineers, but you get to work with people that care about what they do and that care about the greater good, for the good of the entire region and the entire globe.